we get to work with some of our exponential functions, and we get to write an equation. Shh, it's fine. Just let it sink in, you know, just enjoy it. So we're going to look at an exponential function. We're going to take some words and we're going to actually make it into a function and mess around with the problem we have. So today we get to work on those exponential functions. So they want us to write an equation. So we need to kind of come up with a formula, or kind of, you know, like a y equals mx plus b kind of type of thing for our exponential functions that we have, right? So I'm going to give you a nice little cool one. And then we'll write it down and then we'll go through what all the little parts mean, right? So I like to write mine as y equals a. Then I usually do 1 plus or minus b, and all of that's raised to a power of x.
What is that showing?
Pardon me?
What is that like formula showing?
Exponential functions.
It says at the top right there.
Exponential functions. Yeah. Or it's even written here too, exponential functions. All right. So our a, we either call that like our initial value. Oops, keep going in. So either the initial value, or some people just call it the like the starting value. So like our example, we're going to talk about money. A lot of times we talk about money when it comes to our exponential functions. So that initial value or that starting value is like how much money you started with before you invested it, right? I'm going to jump over to this b. Uh-oh. Our b is our, either it's the multiplier, but in money, we usually just call it our rate. And x is our time in years. So the only thing we have not talked about is this 1 that is here and these pluses and minuses. So when it comes to like percentages and decimals, like we like to write out like 100% with that little percent sign, but we never can multiply by like 100 with the percent sign. You always have to turn it into a decimal. So 100% as a decimal is going to be 1, and that's where that 1 comes from. So whatever money you invest, right? So we have our initial value that we invested. You're going to like get that 100%, but then from that 100% of that money that you put in there, either you're going to make money plus, or you're going to lose money, which would be that negative. So that positive or negative ultimately tells us, we're going to just draw. This is either going to tell you if you have a growth or a decay. So if my number is greater than 1, because it would have been 1 plus the rate, I know it's going to be a growth. And if it was 1 minus some value, so like 1 minus 0.2, then we know it's going to be a decay. Does that work? In a sense? It was so nice listening to the birds. They're singing to us. Alright, so let's just jump on into a little problem. So Janice, she would like to have $40,000 to help her pay for college in 8 years. So that means she's in what, like 4th grade? So in 4th grade, she realized, well, maybe she's not going to college right out of high school, who knows, right? But she wants to be able to have $40,000 to help pay for college that she's going to go to in 8 years. And currently she has $1,000 that she wants to invest. Yeah, so we need to figure out what investment rate would compound yearly that would help her reach her goal, right? So we need to kind of come up with a little function, right? So what type of function would best model this situation? Well, it's going to be our exponential function that we just kind of looked at, right? So if we write out our little formula that we had, so we had what? Y equals A 1 plus or minus B raised to the X.
Y equals 1,000.
Yeah. Well, so let's figure out what each one of our letters talk about, or our numbers. So this 40,000, what's our 40,000? That's what she wants to have at the end, right? That's what she wants. So that's going to be your Y. Yep. So 40,000. What's our A stand for? Yeah, initially. So what does she have?
1,000.
She's got 1,000. So there's your 1,000. We know I got her a 1. Do you think it's going to be a plus or a minus? It's going to be a plus, right? Because she wants to make money, so she wants to have an increase. So it's going to be plus. Plus our rate. Yep, we don't know what the rate is. That's what we got to find out. That's our B. And that's going to be raised to the X, right? Oh, sorry, the 8, yes. Because of the years, right? So guess what we need to solve it for? We need to solve it for B, right? What do you think the first thing we probably should do is?
Divide both sides by 1,000.
Yeah, divide both sides by 1,000, right? Divide this guy by 1,000, divide this guy by 1,000. What am I gonna get?
4,000.
4,000?
40.
Or 40? Is that right? Yeah. So 40 equals 1 plus B raised to the, oops, I'm having a hard time writing those 8s. That 8, right? What do you think we got to do now?
Square root of the 8.
Yes, yeah. Almost like the square root, but we're going to take the, what root? The 8th root of both sides, right? So the little 8th root of 40 equals the 8th root of 1 plus B raised to the 8. Oh, anybody want to jump here? Let's jump on decimals real quick. We need the 8th root of 40. So how about 1.59? You guys good with 1.59? So this would be 1.59. And what happens when we take the square root or the 8th root of something listed to the 8th?
They cancel.
Yeah, and you're just going to be left with 1 plus B. Okay. And what are you going to do to get B all by itself? Subtract 1, and then we get B equals 0.59, right? So this is just where we need to be a little bit careful when it comes to now writing this as like a percentage. We want to convert that 0.59 into a percentage because we always like to write that little percentage rate, right? So anytime I go to turn it into a percentage, what do I have to do with my decimal?
Make it to the percentage of like 100.
Yeah, I got to move that decimal over 2 places, and then I end up getting 59%. Right? So if she has $1,000 and she wants to make $40,000 in 8 years, she needs the bank to pay her at an interest rate of 59%. All right. Janice has a friend. Her friend's name is Sarah. Sarah actually has a little bit more money. Sarah has $7,800, and she wants to have though 18,400 20 years from now. So not in 8 years, but in 20 years from now.
Not even more.
Right. Well, we don't know how old Sarah is. Maybe, you know, well, no, well, it's in 20 years, right? 20 years down the road. So what interest rate does she need compounded yearly, right? So we're going to use that same equation. Yeah, so what was it? Y equals A 1 plus or minus B to the X. All right. Do we know what we want to put in for Y?
18,400.
Yep, 18,400. A is our,
7,800.
yep, our initial value, so 7,800. 1, are we going to make money or lose money? Make money. So plus. Do we know our rate? Nope, that's what we got to find out. And how many years? 20. All right. What's the first thing we're going to do? Yeah. And I'm going to come up with 2. We're going to go 397. How about that? Equals 1 plus b raised to the 20th. What are we going to do now?
20th root minus 9.
Yep, the 20th root. That's hard to write. Oops. I'm going to do it in decimals. So we want the 20th root of 2.397. So 1.04. We good with that? 1.0. We'll go 4.5. Why not? Just to make it fun today. And when we take the 20th root of something raised to the 20th power, we just get what's left inside. So 1 plus b. Subtract our 1, 0.045. So we want to write that as a percentage. So what would that guy be as a percentage?
45%.
45?
4%.
So that, right, you got two options. You either just have to multiply it by 100, right, because the percentages goes by 100, or you just move the decimal over twice. So if I move the decimal over twice, I get 4.5%. 4.5%. Right? So if you have $7,800 that you can put in the bank for 20 years and it gets an interest rate of 4.5, you'll have $18,000 at the end of 20 years. Who has a more realistic goal? Janice at 59% or Sarah at 4.5%?
Sarah.
Sarah.